Hi everyone and welcome to topic 3, lesson 3. Today we're going to be talking about what some of the rules are when you're working with exponents and why the rules are the rules. And then we're going to be specifically talking about multiplying exponents today. So a couple different concepts we're going to be working on. And so an example that we're about to go over is something like, oops, let me clear this off. Something like this. So if we had 3 to the third times 3 to the second, we could actually solve that and say, well, we know 3 to the third is 27. We know 3 to the second is 9. So 27 times 9. But what if we wanted to write this again in exponent form? So we would write 3 to the blank, like 3 to the something. What would that something be? And that's the lesson we're going to be talking about today. And we're going to go into a couple different details on that, but I just wanted to give you some context. So these are the types of problems we're going to be looking at today. We're going to watch this video. It's about 2 minutes long, so hang in there with me while we watch this video together.
Consider the expression 7 squared times 7 cubed. What does this expression mean? Write 7 squared and 7 cubed in expanded form to take a look. 7 squared equals 7 times 7. And 7 cubed equals 7 times 7 times 7. To find their product, write all of the factors together. There are 5 sevens. 2 plus 3 equals 5. Notice that the base stays the same while the exponents are added. This suggests the following property: multiplying powers with the same base. To multiply powers with the same base, add the exponents.
Okay, I'm going to pause it right here. So let's go back to our first example here. 3 to the third power times 3 to the second. Just as a refresher, when you have an exponent, the big number is called the base, and the small number is called the exponent. So in this case, the base is 3 and the exponent is 2. Okay, so this is the base, and if you need to, write it down so that you remember, because we're going to talk about the base quite a bit in this lesson. So the 3 is the base, and the 2, we should know by now, is the exponent. So in this situation, we have 3 to the third. So that means 3 times 3 times 3. And this one we have 3 to the second. And these two numbers are being multiplied together. So we're going to say times 3 to the second, which is 3 times 3. So if I wanted to write this as an exponent with the base still being 3, I'm multiplying 3 by itself 1, 2, 3, 4, 5 times. So an exponent would be 3 to the fifth. So I can safely say that 3 to the third times 3 to the second is the same thing as 3 to the fifth. And if you notice, let me get a different color here, I simply added my exponents, 3 plus 2, which gave me 5. And that makes sense because this 3 to the third right here is represented by these 3 to the thirds. And then this, let's grab another color, 3 to the second is represented by these 3's right here. And then 3 to the fifth, if I grab green, shows me that all of those numbers multiplied together gave me 3 to the fifth. Okay, so each group is represented here, but we can say 3 to the third times 3 to the second gives me 3 to the fifth. So in the case of the video that they're doing, I think they did 7 to the third. 7 to the third times 7 to the second would result in 7 to the fifth. And they're about to tell you the rule is that when the bases are the same and the numbers are being multiplied. They have to be being multiplied. Make this a giant multiplication dot. You add the exponents to find the new exponent. Okay, and there's another type of problem we're going to do too, but this is when the bases are the same and the bases are the same and the two bases are being multiplied together. Then you add the exponents. Oops, sorry.
Seven squared times 7 cubed equals 7 to the power of 2 plus 3, or 7 to the power of 5. For any number a that does not equal 0 and integers m and n, a to the power of m times a to the power of n equals a to the power of m plus n.
All right, so here they're giving you this is the arithmetic example, and this is the algebraic example. Algebraic example just means they replaced the numbers with some letters so that you can use it with any set of numbers when you're using this in the future. And with exponents, they almost always use the exponents letters m and n. So just so you know, you'll probably see those letters quite a bit. But just so you know, just like 7 to the second times 7 to the third gave us 7 to the 2 plus 3, this would be like 7 to the second times 7 to the third equals 7 to the 2 plus 3. So it's working the same way, it's just using algebra instead. So write all of this down in your math journal. This is a very important rule that you will use for the rest of your middle school and high school math and college math. If you go through that math in college, you'll need this again. So this is super important to remember. Okay, so here's our example. 5 to the second times 5 to the eighth equals 5 to the blank plus blank, which equals blank. Well, when we have the bases are the same and they're being multiplied, we're going to add those exponents. So it's going to be 5 to the 2 plus 8, and 2 plus 8 is 10. Okay, let's do the next one. Bases are all the same and they're being multiplied. Great, so we can add up these exponents. So we need a 3, a 5, and a 10. We're going to add them up. 3 plus 5 is 8 plus 10 is 18. And let's see. Ooh, this one's a little bit different. This one, I'm going to pull into our notes here. This one has a combination of different strategies and techniques that we need to talk about. So in this situation, we have a couple different things. We have a number in front of another variable. So if we were to write this out in expanded form, we would write, let me get a darker color than green. We would write 2 times, because remember, a number next to a variable symbolizes multiplication. 2 times m to the 10th times 5 times m to the second, 5 times m to the second. And this would be our expression. Now, the rules of multiplication say that we can multiply in any order and any time. So 7 times 8 is the same as 8 times 7, or 1 times 2 times 3 is the same as 2 times 3 times 1. We can switch the order of multiplication and we will still get the same answer every single time. So we're going to do that in this problem so that way we can simplify our exponents. So I'm going to do 2 times 5 first, which is what they're doing here. 2 times 5 first. So 2 times 5 is 10. And then I'm going to do my exponents times my variables times my variable. So m to the 10th times m to the second. Well, m to the 10th times m to the second is the same as m to the 10 plus 2, which now my 10 gets brought over to my answer here, and 10 plus 2 is 12. So if you have a coefficient is a number in front of a variable. If you have a coefficient and exponent, you can still add the exponents together. Just don't forget that you need to multiply the coefficients first, or at some point in your math. So 10, 2, and 12 are still what we're working with here. 10, 2, and 12. All right, so now it is your turn to practice. And good, you get one with a coefficient. So try this one on your own, pause the video, and then come back to check your work. All right, let's go ahead and take a peek at the solution here. Remember, we multiply the coefficients first, so 3 times 5 gives us 15, so I know I'm going to have a 15 in my final answer. And then I'm going to add these exponents. 4 plus 7 is 11, so 15 times y to the 11th is your final answer. All right, so what is different about this new problem that we're looking at compared to the last problem? I'm going to go ahead and take this and put it into our notes here. Hopefully you can see the difference is that this is an exponent being raised to another exponent. This is not an exponent and a base times another exponent and a base. This is a base and an exponent being raised to another exponent. So when we have a situation like this, we're going to treat it differently. So I'm going to clear some of our work here because now we're going to be talking about a new rule. Put this back. All right, our new rule. Let's go ahead and write this in expanded form so we can figure out what our rule is going to be. So 5 to the second is the same as 5 times 5, right? 5 times 5. I'm going to write that in parentheses because it's in parentheses in my original problem. Now my question is, how many 5 times 5s do I have? Hopefully you said I have 3 groups of 5 times 5. Actually, I'm going to do this. Let's take a picture of this. I have 3 groups of 5 times 5. Here's a group, there's a group, and here's another group. Sorry for all that background stuff coming up. It's all of our old notes that I keep covering up. Okay, so I now have 3 groups of 5 times 5. And I did 5 times 5 because I have 5 squared inside of parentheses. So I have my first group of 5 times 5, my second group of 5 times 5, and my third group of 5 times 5. And I did that because this exponent outside of the parentheses tells me I have 3 groups. This one right here, I have 3 groups of it. So now I need to write this as one base and one exponent. So how many 5s do I have total? Well, I have 1, 2, 3, 4, 5, 6. I have 6. Interesting. Can you tell me what you see a relationship between the 2, the 3, and the 6? Do you see a relationship? Hopefully you said, hey, 2 times 3 is 6. And if you said that, you'd be completely correct to find our rule for this problem. So anytime, this is called a power being raised to a power. Anytime you have a power, like 3 to the 4th, being raised to another power, we're going to multiply our exponents. So that would give us the final answer in this situation of 3 to the 8th. And if this ever confuses you, like, wait, I forget if I'm supposed to add them or multiply them, write them out in expanded form. 3 times 3 times 3. I think I only said that 3 times 3. So that you can see, hey, this is only one set of parentheses. I need 2 sets of parentheses. And then you'll remember, hey, this is multiplication. I need to multiply. So friends, just like in our first video, this video is coming to an end in its time. So I am going to stop the video here and record a second video for part 2 of this video lesson. And I do promise the next one will be much shorter and we'll wrap it up in part 2. So go find part 2 video and I'll see you over there in that lesson.